Good day, grade 10 learners. Welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Today, grade 10s, we're doing an interesting topic, which is trigonometry. So we're going to learn about trigonometric ratios and their reciprocals. That's what we're going to learn during this lesson. Let's be ready for our lesson, grade 10s. Let's be ready. I want you to sit, make sure that you're comfortable. You have your workbook, we have your pen, you have your pencil, and your calculator. Okay, let's be ready for our lesson. You can even write today's date and then write the topic, trigonometric ratios and their reciprocals. Let's do that. Let's do that. And then we're going to start our lesson. Okay, right. Let's start our lesson. What we're going to learn about today. Right, by the end of this lesson, grade 10s, we are going to define trigonometric ratios. Using what? Using a right-angled triangle. Do you remember what a right-angled triangle is? Don't worry, I'm going to remind you. So we're going to define what is sine theta, what is cos theta, what is tan theta. You see there's theta there. Sine theta, cos theta, tan theta. There's nothing like sine or sin on its own, cos on its own, or tan on its own. It must be sine angle, cos angle, tan angle. Every time. Remember that. Okay? And then we're going to define the reciprocals of this. What is a reciprocal? I'm going to remind you about reciprocals, right? Which are called the cosec theta, sec theta, and cot theta. And we're going to define these using what? A right-angled triangle. Okay, right. This is what we want to learn today. Just defining this, understanding what these trigonometric ratios are and what their reciprocals are. This is what we have to learn today. And remember our WhatsApp line 079 454 9535. For this lesson, use this line 079 454 9535. Please, let's discuss during the lesson. Don't wait. Okay, don't wait. If there's something you don't understand, ask now. And then we'll have time to what? To revisit the concept that you did not understand. And your input, please. Your input has helped us a lot. You know that. If I'm moving fast, tell me, and then I'll slow down. If you have something that you missed, you don't understand, tell me. We'll go back and revisit it, okay? Right. Trigonometry in real life. Why are we learning trigonometry? Is it useful? Can we use it in real life? It is used a lot. Trigonometry is used a lot in real life. So trigonometry is the study of the relationship between sides and the angles of a triangle. This study between the sides and the angles of a triangle. Please don't write it down. Don't write it down. Just listen. Right. Trigonometry is the study of the relationship between the sides and the angles of a triangle and calculations based on them. And the calculations based on these sides and angles, particularly the trigonometric functions. Where do we use trigonometry? These calculations are used in areas like surveying, navigation, aviation, satellite systems. We use trigonometry. Astronomy, we use trigonometry. Land surveying, cartography drawing, which of maps, also we use trigonometry. You see that is used a lot. Okay, so make sure you understand this topic from today. Okay, make sure you understand this topic from today. Let me give you another good example of where we can use trigonometry. A simple one, a very simple one. Right. Let's say we want to find the height of this building. You know this building is a very popular building. Are we going to get a tape measure and start climbing the building? You see, it's going to be difficult. We can use trigonometry to find the height of this building. If we have the horizontal distance, like the distance on the ground from the observer and the building. If we have this distance, we just measure this distance and we measure the angle. There is an instrument that can be used to measure the angle. You can even make one in class, a simple one, using a protractor, right? So we can measure this angle here, find the angle theta here. And then with this angle and this distance, we can easily find the height using trigonometry. You see that? I'm not going to go into detail on how we're going to find that because we're going to be doing those calculations later. But remember this example when you start those calculations. Today, remember, we're just doing what? Defining trigonometric ratios. You see the application of trigonometry? It can be used in a lot of areas, right? And then in grade 8 and 9, we learned about triangles, and we learned about right angle triangles because we're going to define trigonometric ratios using right angle triangles. And the Pythagoras theorem, do you remember the Pythagoras theorem? We're going to use it in this lesson. Right, let's just do a simple activity. I want you to name the given triangles. Let's just remind ourselves about the types of triangles. Right, 1 minute on these 3, just 1 minute. Right, welcome back, greatest. Did you manage to answer the questions? What is the first one? This one. What is the name of this triangle? It is an isosceles triangle. Isosceles triangle, because AB, side AB is equal to side AC. There were two sides that are equal, meaning that also we have two angles that are equal. We say angles opposite equal sides are equal, or sides opposite equal angles are equal. But just two sides are equal for now. Let's just say two sides are equal. It's an isosceles triangle. And then the second one, this one, what type of a triangle is it? It's a right angle triangle. Why do we say it's a right angle triangle? Why do we say right angle? Because it has a 90-degree angle. This angle is 90 degrees. So a triangle with a 90-degree angle is called a right angled triangle. We're going to be using this triangle a lot in this lesson. Remember that. A right angled triangle. And then the third one, this one, what do we call it? What is the meaning of this? We have 1 here, and then 2 there, then 3 there. What is the meaning of that? It means all the 3 sides are different, are of different lengths. So this is what? A scalene triangle. It's a scalene triangle. Even the angles, they are going to be different. All the 3 angles are going to be different. It's a scalene triangle. Right. What about this one? Let's name this one in 30 seconds. I'm going to wait for you. 30 seconds, let's name this triangle. Are you done, Cretans? Okay, even if you're still trying to think what type of triangle is this, so let's just do it. We're going to do corrections, isn't it? Right. Now, all the angles are equal. All the angles are equal, and they're equal to 60 degrees each. And all the sides are equal. It's in what? Equilateral triangle. Okay, these are type of triangles. Let me just give you one more question, and then after that, we're going to start defining our trigonometric ratios. Okay, one more question. Let's go there. Right, I'm going to give you 1 minute. Let me just read the question. Given right angle triangle is what? A 90-degree angle, ABC, with reference angle. It means you're looking at the reference angle alpha here. Okay, which side is the hypotenuse? I want you to use your knowledge about the right angle triangle and the Pythagoras theorem. We did this in grade 8 and 9. Which side is the hypotenuse? And then which side do you think is opposite angle alpha? Which side do you think is opposite angle alpha? And then which side is adjacent? Adjacent means next to. Okay, even if you don't know it, I'm not saying you know. I want you to try. Don't be afraid of trying. Right, which side is adjacent next to angle alpha? Okay, if you can discuss without disrupting or disturbing others, you can do that. For 3 minutes, let's discuss these three. Welcome back, grade 10s. Remember, WhatsApp line for this lesson is 079 454 9535. Remember that. Now let's answer our question. The hypotenuse. How do you identify the hypotenuse for a right angle triangle? 1, it is the longest side of a right angle triangle. Okay, but sometimes you may find that it may be difficult to see which one is the longest side if you look at some of the diagrams. So how do you identify a hypotenuse? It is the side opposite the right angle. So this is our right angle here. This side is opposite the right angle. So this is the side AC. That's the hypotenuse. You see, like this one is like an arrow pointing. You see? The right angle triangle is like, the right angle is like an arrow pointing towards the hypotenuse. That's how you identify the hypotenuse. So AC is the hypotenuse. Which side is opposite angle alpha? So now, to say the side is opposite or adjacent, you have to be referring to an angle. You see that? So this is angle alpha here. You may be having another angle here. Let's call it X. You see that? If it comes to X, AB is next to X, but it is opposite angle alpha. So we're referring to angle alpha here. The side which is opposite angle alpha, that's AB. AB is opposite angle alpha. And then adjacent, next to angle alpha, just next to, that's the side. BC. BC is just next to angle alpha. So which angle are you referring to? Very, very important. Because if we come into X here as the reference angle, AB is adjacent to angle X. But if you check, AB is actually opposite angle alpha. And then BC is adjacent to angle alpha. But if you check, it's opposite the angle that I've named X. You see that? So you have to know which angle am I referring to before you name your sides: opposite, adjacent. But the hypotenuse is always fine. It's always the side opposite what? The 90-degree angle. You see that? So please, we're going to be using this. I don't want anyone to lose marks. We're going to be doing an activity on this. Right. So you may find angles named by means of Greek letters. So you've heard me saying angle alpha. This means angle alpha. This means alpha. That's the sign for alpha. Okay, some of you are doing physical sciences, so you know you use this also a lot. Beta, okay, theta. You see that? So you may find that when I'm saying beta, this means theta, this means beta, this means alpha. Okay, but sometimes you use the vertices of the triangle. If the vertex is A, like let's say, you know the vertex, the corners of the triangle. Let's say this is A, B, C. We can use the vertices to name the angles. Like angle A is this one, angle B is this one, angle C is this one. You know that, okay? But you may also find this. Just take note of that. Like naming the sides of a triangle. Now, when alpha is the reference angle, yeah, which side is opposite? Is like redoing what we just did under baseline activity. Which side is the opposite side? AB is the opposite side. AB is the opposite side. Which side is the adjacent side? BC is the adjacent side. BC is the adjacent side. Which side is the hypotenuse? AC is the hypotenuse. Okay, I want you to write your short notes here. I'll give you 1 minute. Don't need to write just opposite side. You can say op side. Adjacent side, say arch side. Then hypotenuse, just hat. You see that? Okay, for 1 minute, just write your short notes. Right, welcome back. Grade 10s. Let's see the next diagram. Now, when the reference angle now is another angle, let's say angle beta or angle theta. I've used theta, sorry for that. Now, I've used theta now. You see, the previous one This was our reference angle. Now this one now, same diagram, but now I've used angle theta as the reference angle. So when theta is the reference angle, which side is opposite angle theta? BC, you see that? BC is opposite angle theta. Which side is adjacent angle theta? AB is adjacent angle theta. And then which side is the hypotenuse? AC is the hypotenuse. Okay? Let's have our 1 minute and you write short notes. You don't need to write everything like we have it on the slides here or on the screen. Just write your short notes the way you understand it. Okay? 1 minute. Right, welcome back, Cretans. Definitions of the trigonometric ratios. A right angle triangle is used. Remember our objectives? We are going to define trigonometric ratios using a right angled triangle. So we have our right angled triangle here, which is ABC. And then we are saying the ratio. What ratio? Opposite side over hypotenuse is called sine of angle theta. The ratio opposite side over hypotenuse is called sine of angle theta. I'm going to be giving 1 minute for each statement. Now I want you to write just this part. The ratio opposite side over hypotenuse is called the sine of angle theta. 1 minute for that. Welcome back, Cretans. Remember WhatsApp line Cretans 079-454-9535. Right, that's the first ratio. What are we doing today? Defining trigonometric ratios. Sine of angle theta, or it can be sine of angle A. It's not about theta every time. It can be sine of angle X, sine of angle A, sine of angle P. Right, so I'm going to be using theta just for this lesson. Sine of angle theta is opposite side over hypotenuse. We know how to identify our opposite side now. We know how to identify the hypotenuse. We know how to identify the adjacent side when referring to a particular angle. Then the ratio adjacent side over hypotenuse is called the cosine of angle theta. Write that one down in 1 minute. The ratio adjacent side over hypotenuse is called the cosine of angle theta. Let's write it down. 1 minute. Right, welcome back, grade 10s. Let's do the last ratio. The ratio of what? Over what? Divided by what? We have the ratio opposite side divided by adjacent side. Opposite side over adjacent side is called tangent of angle theta. The opposite side over adjacent side is called tangent of angle theta. So these are the three ratios. Let's write our last one for 1 minute. This one for 1 minute. Right, welcome back, grade 10s. Let's continue with our lesson. Please send us your input 079 454 9535. If you have any questions, there's something you do not understand, please send us your questions. Don't forget to just name your school, okay? Name your school and send us your question. Right, so we've talked about this, just repetition. So we've said that the ratio opposite side of hypotenuse side is called the sine of angle theta, but I want you to write it like this now. I want you to come to this part. Don't write everything. We said the ratio opposite side of hypotenuse is called what? Sine of angle theta, okay? I want you to add this. Just say sine of angle theta is written as, okay, I'm just drawing an arrow there, is written as sine theta. Okay, so what does sine theta mean? You've heard sine theta, cos x. What does that mean? Sine theta means sine of angle theta. Tan theta means tangent of angle theta. And then cos theta means cosine of angle theta. Please just add this part only. Don't worry about the rest. Sine of angle theta means sine theta. Write that. 1 minute. Right, welcome back. Let's go to the next one. We say that the ratio adjacent side over hypotenuse is called the cosine of angle theta. How do we write cosine of angle theta? We just write cos theta. Right, I'm going to give you 30 seconds now, not 1 minute. Just write this cosine of angle theta. How do we write this? We say cos theta. Okay, for 30 seconds, write this statement. I have written in red there. Cosine of angle theta is written as cos theta for 30 seconds. Right, it should be done by now. Grade 10s, please remember WhatsApp line 079-454-9535. Right, let's go to the next one. How do we write tangent of angle theta? The ratio opposite side over adjacent side is called tangent of angle theta. How do we write that? We just say tangent of angle theta. We write it like, we say tan theta. So I don't want to see a mistake where people just write sine, tan, cos like that. No, there's nothing like that. Cosine of what? Cosine of angle. Okay, cosine of angle A, cosine of angle X. That's a complete statement. Okay, so tan theta means tangent of angle theta. 30 seconds. Let's copy this part, the one I've written. 30 seconds. Are you done, grade 10s? Please send us your input. We don't want anyone to be left behind. No one should be left behind. We have to move together. 079-454-9535. Okay? If there's something you don't understand, let us know. Okay, right. Let's continue. Right, now we have been talking. I've been talking. I want to give you an activity. I'm going to give you an activity very soon. Right, applying what we have discussed. We have to apply what we've discussed. Right, so now there's a mnemonic that can be used, okay, to assist us understand these trigonometric ratios. Maybe you may have a different one. It's not like you're going to be examined on this. No. This is just here to assist you. Remember trigonometric ratios. And people say it differently, put it differently, and pronounce it differently. Okay? This is just sort of informal to just assist you understand what you call these trigonometric ratios. So I pronounce it as SOHCAHTOA. SOHCAHTOA. Right. So the S there for SOHCAHTOA there is for sine theta. And then how do we find sine theta? We say opposite side over hypotenuse. This is how you find sine of angle theta. Okay? And then the ka part. Cosine of angle theta, cos theta. How do we find cosine of angle theta? Is adjacent side over the hypotenuse. Please remember that. And then the TOA part, the T there for tan theta, the O for opposite side over adjacent side. You don't need to write everything. Just write the part which is in the box, the SOHCAHTOA part. You remember. You don't need to write all those errors there. No. Don't. Just SOHCAHTOA. 30 seconds. Right, Socator. Right, well done, cretins. We have this part. Okay, this may assist you. This may assist you. Right, are you ready for the activity? Now we need to apply what we've been discussing. Right, consider the following diagram and use it to answer the questions that follow. State the following. Sine theta. I want you to use the sides AB, BC, AC. You naming. You don't need to write opposite side over adjacent side. No, I want you to name the side. The sides that we have in this triangle, there is AC, there is BC, there is AB. I want you to use those sides. If sine theta, I'm not saying it's correct, if sine theta is BC over AB, I want an answer to be like that. BC over AB. Something like that, okay? So what is sine theta? What is cos theta? What is tan beta? 3 minutes. Let's do this. You can discuss maybe in pairs. That would be great, but don't make noise. 3 minutes. Welcome back, cretins. Let's mark our work. Now we're marking our work, okay? Right. Now, sine theta. Sine theta, our reference angle is theta here. And let's just have our Socator just to remind ourselves. Socator. Right, sine theta is opposite over hypotenuse. So which side is opposite angle theta is AB. Okay, and then which side is hypotenuse is AC. So sine theta is what? It is AB over AC. Let's mark that. Okay, let's do B. I've given you the answer before discussing. It's fine. Now, SOHCAHTOA, adjacent over hypotenuse. AH, adjacent side over hypotenuse. So now, which side is adjacent to theta? This is the side which is adjacent to theta, that's next to theta. The hypotenuse is AC. So it means cos theta is BC over AC. Then tan beta, please be careful. I know maybe some of you made a mistake, thought it's tan theta. Tan beta, you have to be careful there. Tan beta, this is the angle we're talking about. This is the angle we're talking about. And then tan beta is opposite over adjacent. Which side is opposite angle beta? Is BC, this side. BC. Which side is adjacent to angle beta? Is AB. You see that? So to check which angle we are referring to is very important. So tan beta is BC over AB. Please mark that. Okay, mark that. Okay, right. If you made mistakes, it's okay. We learn from those mistakes. If you did everything correctly, well done. Okay, right. And then consider the following diagram and then answer the questions that follow. Let me give you 2 minutes for this. Now we have an idea. Okay, let's do this for 2 minutes. And then after 2 minutes, we're going to mark our work. We're not going to discuss a lot. Okay, we just mark our work and then move on. Let's do it for 2 minutes. Welcome back, returns. Thanks very much to Sungu Secondary School for greeting us. We are here. We're doing trigonometry. Trigonometry is an interesting topic. If you check the first part, we talked about what is trigonometry and also where we apply it. Thank you very much. Please, if you have asked questions, feel free to send us your questions. Right. Now let's answer this. We'll be a bit fast here so that we move on. But remember, we just did this, okay? So now it should be better now. And then remember our SOHCAHTOA. Sine beta is opposite side over hypotenuse. Which side is opposite? This side. Which side is hypotenuse? This side. So sine beta is BC over AB. BC over AB. Okay, I always make mistakes sometimes when it comes to this. So I make sure that I check. I have to check because if I move fast, I make mistakes. So cos beta is adjacent over hypotenuse. Adjacent over hypotenuse. Where is adjacent for cos beta? This is the side adjacent. Hypotenuse, this is the side. So it's AC over AB. Okay, mark that. And then tan theta. Our reference angle has changed now. It's now this one. Which side is opposite angle theta? It is AC, because tan theta is opposite over adjacent. And then which side is adjacent to angle theta? Is BC. So it means tan theta is AC over BC. Okay, mark that. Well done. I know you got everything correct now. Okay, so this is how we define trigonometric ratios grade 10. Nothing more than this. This is how you define trigonometric ratios. Please understand this part, and it's going to be there in your test and examinations, how to find, to express these trigonometric ratios using the sides. Remember, sometimes how do we name the sides of a triangle? This side will be a small letter C, opposite the angle. This side will be small letter B. This side will be small letter A. Remember that. So sometimes you may be using these small letters. Instead of saying AC, you can say B, small letter B. Instead of saying BC, you use small letter A. Instead of saying AB, you use small letter C, something like that, okay? Right. We cannot cover everything in this lesson, but just have that. Once you understand this part, then you're going to enjoy your trigonometry. Right. Should we move on? Right. We're left about 12 minutes. I want us to talk about the reciprocals. Reciprocals. Right. I want us to talk about reciprocals. Let's understand, what is a reciprocal? What is a reciprocal? What is a reciprocal of 2 over 3? What is a reciprocal of 2 over 3? It is the multiplicative inverse, isn't it? Remember, the numerator goes up. The numerator is already up. The numerator goes down, the denominator goes up. So the reciprocal of 2 over 3 is 3 over 2. You see that? That's a reciprocal, the multiplicative inverse. So we have reciprocals when it comes to trigonometric ratios. We have reciprocals. So remember that reciprocal of opposite side over hypotenuse side is going to be what? Hypotenuse, you see this one now, it goes up, this one goes down. That's a reciprocal. Reciprocal of opposite side over hypotenuse is the hypotenuse over the opposite side. Don't write this, I'll tell you what to write. Okay, just know that. Like you invert, inverting. You see that? That's a reciprocal. So what's the reciprocal of sine theta? Because this is sine theta. So what's the reciprocal of sine theta? Is hypotenuse over opposite side. Does it have a special name? Yes, it has a special name. I'll give you that special name later. Reciprocal of adjacent side over hypotenuse side, or just hypotenuse, okay? Right, we use a side for adjacent side, opposite side, hypotenuse is just fine, right, without the side. So, adjacent side over hypotenuse, that is cosine of angle theta. Then the reciprocal of cosine of angle theta will be hypotenuse over adjacent side. We've just inverted. This goes down, this goes up. That's the hypotenuse. Please don't write this. I'll give you just short notes that you're going to write. And then the reciprocal of opposite side over adjacent side. This is tangent of angle theta, tan theta, or tan x. Right. It is the adjacent side over opposite side. That's the reciprocal. So if you understand the trigonometric ratios, then it becomes very easy to understand their reciprocal or their reciprocals. Okay? Right. So how do we name these reciprocals? I want you to now to write these two. Just wait for me, then I'll tell you what to write. The cosecant function cosec theta. Just from here, cosec theta is the reciprocal of sine theta. You're going to write that, wait for me. You're going to write that part. So the cosecant function, which is called cosec theta, is the reciprocal of what? Of sine theta. And then remember that for triangle ABC, cosec theta is going to be 1 over sine theta, okay? Meaning that hypotenuse over opposite side. Remember, sine theta is opposite side over hypotenuse. Now, cosec theta, it sounds like it's cos. You understand that? But it is not. Remember that. So cosec theta is not the reciprocal of cos theta. It is the reciprocal of sine theta. And it's hypotenuse divided by opposite side, which is reciprocal of opposite side divided by hypotenuse. Let me just explain. I'll explain using this once, and then the rest we just tell you. Right, it's 1 divided by sine theta, meaning that it is 1 divided by opposite side over hypotenuse. And then remember, when you're dividing some fraction, we tip and times. We multiply by, we tip and times, okay? We tip and times. So it becomes 1 times hypotenuse over opposite side. You see that? You see, remember that? You see that? So that's the reciprocal. So I want you to write this part for 1 minute, from there up to there, and then just this part. Just those two for 1 minute. Let's do that. Welcome back, returns. Thank you very much, Sorry Secondary School. You have received your work. Thank you very much. Let's continue trying our best. Remember, do mathematics every day. It's a very, very interesting subject. Make sure every day you practice mathematics, okay? And don't create gaps. Every concept, make sure you understand it. What you are learning now, you're going to use it in the next lessons, in the next topics, in the next grades, okay? Right. And then this part, just note that the hypotenuse over opposite side is the flip side of opposite side over hypotenuse. You don't need to write this. We've been saying it, okay? We've been talking about it. Now, let's go to the next one. Sec theta is the reciprocal of cos theta. Please take note of that. Cosec theta is reciprocal of sine theta. And then sec theta is the reciprocal of cos theta, okay? And then how do we write it? We say, oh, sec theta is just second function, okay, second function. And then I want you to write this part here, and then this part there. So sec theta is hypotenuse over adjacent side. Remember, cos theta is adjacent side over hypotenuse. So sec theta is the reciprocal, which is hypotenuse over adjacent side. Let's write our notes for 1 minute. Right, welcome back. Let's do the last reciprocal. Is reciprocal for what? For tangent of angle theta, of tan theta. What is it going to be called? What is it going to be called? Let's find out. Now, on this part, okay, we've been talking about the flip side of the other reciprocal. And then the cotangent function, cot theta, is the reciprocal of tan theta. Cot theta is reciprocal of tan theta. What is tan theta, by the way? Opposite side over adjacent side. So what will be cot theta be? It's going to be adjacent side over opposite side, which is the reciprocal of opposite side over adjacent side. Okay, right. Let's just write that. Cot theta 1 over tan theta, which is adjacent side over opposite side. Just this part, these two, for 1 minute. And then after this, we're just going to do a short activity. And then we summarize our lesson after that. Let's copy this for 1 minute. Right. Before we move on, there's a question. What is the reciprocal of cosec? I want to put it this way so we don't get confused. We have our trigonometric ratios, which are 3. Sine theta. What is the reciprocal of sine theta? Cosec theta. Let's just move one direction from trig ratio to its reciprocal. Just that. Because if we say reciprocal of cosec, we are going back to the trig ratio. Okay? So now sine theta, reciprocal, cosec theta. Cos theta, the reciprocal, sec theta. Tan theta, the reciprocal, cot theta. Okay? Right, just those 3. And then I want us to do this activity. If you can do it in 1 minute. 1 minute, can you try? I know we're just ending our lesson now. 1 minute, and then after 1 minute, we mark first, and then we conclude our lesson. Let's do it in 1 minute. Right, welcome back, grade 10. Let's mark our work, and then after that, we're going to summarize our lesson. Right, I'll still use my soccer tool, although it's reciprocals. What were the questions? I forgot the questions. Okay, let me go back a bit. Cosec theta, theta, and then beta. Okay. Right. Cosec theta is the reciprocal of sine theta. Sine theta is opposite over hypotenuse. So it means the reciprocal is going to be hypotenuse over opposite side. You see that? So for theta, hypotenuse AC, opposite side AB. So it's going to be AC over AB. Okay? Right, and then sec theta, reciprocal of cosine theta. Cosine theta is adjacent over hypotenuse. So it means the reciprocal of cosine theta must be hypotenuse over adjacent. Theta, hypotenuse, AC, adjacent, BC. So it's going to be AC over BC. Okay, mark that. And then the last one is cot beta. We have to be careful there. Our reference angle is beta. Tan beta is opposite side over adjacent side. So it means the reciprocal is going to be adjacent side over opposite side. Adjacent is AB, opposite side is BC. So cot beta is AB over BC. Mark that. Okay? Right. Let's take a short break and then we'll summarize our lesson after that.
2, 1, your life.
Do you know that you are different? Do you know that your fingerprint is different? It's different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Today, we learned that sine theta is opposite side over hypotenuse. Hypotenuse. And then cos theta is adjacent side over hypotenuse. And then tan theta is opposite side over adjacent side. And then we learned about the reciprocals of these trigonometric ratios. Okay, trigonometric ratios. Right, we said cosec theta, which is the reciprocal of sine theta, is hypotenuse over opposite side. And then sec theta, which is the reciprocal of cos theta, is hypotenuse over adjacent side. And then cot theta, which is the reciprocal of tan theta, is adjacent side over opposite side. Thank you very much, great friends. We are going to meet in the next lesson. Please don't miss the lessons. Goodbye and enjoy the rest of your day. Thank you.